Hi everyone, in this playlist of videos we're going to be looking at alligation alternate. So what is alligation alternate? Well, one way to think about it is, let's say in your pharmacy you've received an order for a 5% solution with a particular active ingredient, and you do not have that solution with that exact concentration on hand, but maybe you do have a solution with that same active ingredient with a 25% concentration and also a 3% concentration. So the question is, how can you mix these two together, the 25% solution and the 3% solution, in such a way that you'll arrive at this a solution with that 5% concentration? So really the question becomes, what ratio is needed that will produce that 5% concentration? So how many parts of the 25% solution and how many parts of the 3% solution are needed to arrive at this concentration of 5%? And that's really what alligation alternate is about. These types of problems. So let's go ahead and take a look at an example.
Okay, the problem says, in what ratio should 25% weight to volume and 3% weight to volume hydrogen peroxide solutions be mixed to prepare a 5% weight to volume hydrogen peroxide solution? So for this, we can set up a grid to help us organize our work. It might remind you of what a tic-tac-toe grid would look like. But our target concentration here is the 5%. So I'm going to put that in the middle of our grid here. And the higher of the two concentrations we're going to use to get to this 5% is 25%. So I'll put a 25 here. The lower concentration that's available is 3. So the question is really asking us, we have a 25% solution available and a 3% solution. In what ratio, in terms of parts, should we mix these together to arrive at a 5% concentration? Okay, so if we look at the numbers diagonally here, 25 minus 5 is 20. And we're just looking for the absolute difference. 5 minus 3 is 2. So really, very quickly, we've arrived at that the solution needs to be 2 parts the 25% solution and 20 parts the 3% solution. So just to emphasize that, so the 2 here, of course, that corresponds to the solution with a 25% concentration. The 20 here corresponds to the solution that has a 3% concentration. So what does this mean here? So that means, for example, I could take 2 liters of the 25% solution and 20 liters of the 3% solution, mix those together, and the resulting solution would have a 5% strength. Or I could take 2 milliliters of the 25% solution and 20 milliliters of the 3% solution, mix those together, and again, I would have a solution with a strength or percentage concentration of 5%. The other thing to note, 2 to 20, a ratio, you can always reduce a ratio in the same way you might reduce a fraction. 2 and 20 do have a common factor, in this case a common factor of 2. Divide both numbers by 2, we're going to get a ratio of 1 to 10. So this would also be a correct answer to the question here. They're really the same answer. You don't necessarily need to reduce your ratio to lowest terms, because if I just use 2 to 20 for a calculation, I would still arrive at the same answer that I would get if I use 1 to 10. But you should be aware of that. So that's so now you see how, again, if we have 2 solutions, one with 25% concentration and another one with 3% concentration, we need to get to a 5% concentration. Following this method here, we ended up with 2 parts the 25%, 20 parts the 3%. So, and if we mix these 2 solutions together using this ratio, we will get a solution with a 5% concentration.